Hey guys, welcome back to my channel. Um, I tried a new webcam, so hopefully this works better. Um, Yesterday I was having some thoughts. Um, we would take at least 5, 6 more sessions in order to complete the review. And I thought, is that really efficient? Isn't it really better if we just go through one chapter or one template and then try to use it on many different questions involving that templates? So yeah, I decided for my growth, uh, I would just focus on one template and solve like 10, 12 questions and then try to get try to master that one template and then move on to the next template and so on and so forth. So we already looked at the 2 pointers from the previous templates review session. So today I think I'm going to uh, explore the questions involving that template. I'm just going to share my screen. If you go to Leetcode, there's plenty of questions uh, using 2 pointers, as you can see. 2 pointers, uh, yeah, variety of difficulty of questions. But for today, I chose 2 easy questions to refresh some problem solving skills. And yeah, it took me like 4 or 5 hours. Uh, not 5 hours. Let's say maximum 4 hours to solve this question. So let's try to solve it together. Okay, so first one that I tried was remove duplicates from sorted array. So given an integer array num sorted in non-decreasing order, I have to remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same, then return the number of unique elements in nums. So what we have to return in number of unique elements. Um, as you can see in the output, there's 2 because there's only 2 unique elements. Um, if you can see test case 2, we can see that the output is 5 because there's 5 different elements because we removed the duplicates. 1 second. Yeah. So let's try to solve the question. So if we looked at the templates, so this was a template, right? We initialized left and right pointers, and then while left is smaller than right, in most cases, we do some logic with left and right, and if condition is right, we plus left, right, -1. This is the normal case, but it could differ based on the question. For this case, the edge case, the base case was um, obvious, right? So if the array is empty, then we have to return 0. So that part was pretty clear. Uh, so if not nums, then return 0. Initialize pointers. Okay, it's always this video. 1 second. Yeah, hopefully it works now. Yeah, left is 0. And then we iterate through the array with the right pointer. So the right in range 1 nums. Um, 1 and length of the until the length of the nums, right? Yeah. And then when we find a unique element, so we're iterating through the element array and trying to find a unique element. So if the element that the right pointer is pointing at um, is not equal to the element, because we're coming from both sides. We're coming from both sides, and then we're seeing if the element that both pointers is pointing at is um, different. And if it's different, it means that it's a unique element, right? So left, We then update the value. So nums left equals nums right. And then we also move the left pointer. And then after that, return the unique elements, which should be the left plus one, right? So we started at the first element for our left, and it kept track of the position of the pointer in the array. The right pointer iterates through the array starting from the second element, um, which is right equals one. So here, and then for each element, nums right, we compare with nums left, and in nums right is different from nums left. We incremented left and updated nums left with nums right. So it put the unique elements in the correct position. After the loop, left plus one gives us the number of the unique elements. We plus one because nums is left is zero index, right? So let's if we try to run this code. Yeah. No, come on. Um, let's run it again. Wrong answer. Oh, the order is different. I think we should move the pointer first and then update. Let's see if this is correct. Yeah, so that was correct. Okay, let's quickly move on to the next question. So this was also the one using two pointers. We have to find the index of the first occurrence in the string. Given two strings, needle and haystack, we have to return the index of first occurrence of needle in a haystack with -1 if needle is not part of haystack. So you can see for each test case, and they're going to provide us with a haystack and then needle. You can see that SAD occurs at index 0 and also at index 1, 2, 3, 4, 5, 6, 6, right? So first occurrence is at index 0, so we return 0. Same goes for test case 2. It hits the base case where the needle is not found in a haystack, so we return -1. So it is pretty obvious that we have to start with the base case, right? Or we don't have to start with base case. We can just put everything together and then later um, specify the base case. But for this question, I've initialized the left as well. Left equals 0. No. Left answer equals 0. I think this also works. Right equals what is right? So right equals length of the array minus the length of the needle, because this is because we're only comparing the starting valid starting positions where a full needle can fit within haystack. If we look at the whole array, then there might be a chance that a needle cannot fit. So that's why we specify this and compare this valid starting positions, which is length of the array minus length of the needle. So yeah, and then we do a loop. So while left pointer is smaller than right pointer, so while the left pointer is still at the left side of right pointer, we're gonna keep incrementing the left pointer like seen in the template. But before that, we're gonna do the condition. So what was the condition? Oops. I don't know why the indentation is wrong. Maybe I did something wrong here. Yeah. I think this one is right. Okay, so the condition was that if array left index 2 left plus length of the needle, then this needle, we compare the substring with the needle, and if it is true, we return left. If not, we keep on moving the left pointer and then keep on comparing. So plus 1, right? So what we did there, we extract the substring of haystack starting at left, and then a length equal to the needle. So if this substring matches the needle, then we return left. Otherwise, we increment the left. Now, at the end, if the no match is found, so that was the base case, we return -1. So let's see if this works. No, no, so this is not possible. Length of the array. Length of the haystack. Haystack, because we're trying to find the haystack. Yeah, so we can see that it works, guys. This indexing was a bit of a trouble because I first started and then it kept getting errors that were not it's out of scope. But after specifying the starting position, it worked. So it's important to always always check if the problem specification is out of scope. But yeah, that was a gentle solving frenzy starting position of the 2 pointers. Tomorrow we're gonna try some medium questions as well. So yeah, thank you guys all for listening. And if you guys have any questions, leave it as a comment below.